Hello friends, in this problem, the two parallel plate capacitors with area A are connected through a conducting spring of natural length L in series as shown in the diagram. Now plates P and S have fixed positions at separation of D. Now the plates are connected by battery of EMF E as shown. Now if extension in the spring in equilibrium is equal to the separation between the plates, then we have to find the value of spring constant. So let us first again redraw this diagram in order to solve this problem. So we have a system of two capacitors connected by a spring between them having area equal to A, and this separation I am assuming to be equal to X, and a spring of spring constant K. Further, it is given that this distance is equal to D. This distance between the outermost plates is given to us as D. Now we can write the final value of L, that is the final length of the spring, to be equal to D minus 2x, while the initial length of the spring given to us in the problem was L. So from here we can find the extension in the spring. So from here I am finding the value of extension produced in the spring, that will be equal to final length of the spring minus its original length, which is equal to x. Actually it is given the problem that the final extension of the spring in equilibrium is equal to the separation between the plates, and since I have assumed that separation between the plates is x, therefore I am writing this extension to be equal to x, which is given in the problem. So from here we can find the value of x, which comes out to be equal to d minus L the whole upon 3. Now with the help of this expression we can write the value of force exerted by spring will be equal to kx, and this force has to be equal to q square by 2a epsilon naught, that is the force between the plates of a charged capacitor. So this is the condition for equilibrium. So I am equating these two forces. On equating these two forces, that is expression 1 and expression 2, we get q square by 2a epsilon naught should be equal to kx, where the value of q should be equal to C equivalent into E, where C equivalent of the system is C by 2, since both these capacitors are connected in series. Now the value of C will be equal to epsilon naught A by D, where the value of D is the separation between the two plates of a capacitor. Now substituting all these values, we finally get, now putting all these values, we finally get the value of K, which comes out to be equal to 27A epsilon naught E square divided by 8 D minus L cube, which is our final desired result. Thank you.